Welcome all of you in this session. My name is Dr. Vishal Patil. I am working as an associate professor in Department of Mechanical Engineering. The name of the subject is thermodynamics. In today's session, we will study the basic fundamental concepts related with the heat transfer. In previous video lectures, we have studied the basic fundamentals of heat and work. In today's session, we will study the basic points related with the heat transfer. The content for this presentation is heat transfer. Second one is objectives of heat transfer. Third one is applications of heat transfer. Next one is basic concepts related with the conduction, applications of conduction, radiation, wave theory or classical theory, radiation in the terms of quantum theory or Planck's theory, characteristics of radiation, convection, and Newton's law of cooling. The first point is heat transfer. The heat is nothing but energy transfer without change in mass. The heat transfer deals with the study of different ways of modes and estimation of rates of energy in transit form. The flow of energy is the basic cause behind any process in the world. Hence, the process or phenomena in any science, the subject is bound to have its role in it. Naturally, energy always flows from high temperature region to the lower temperature region. In a broader sense, there are three modes of heat transfer: conduction, radiation, and convection. The conduction and radiation are the fundamental physical mechanism, while convection is really the conduction as affected by fluid flow. Conduction, the example of conduction is a metal bar that is heated at the end becomes warm at opposite end due to the heat flow through it. The conduction has strong basis in the kinematic theory of physics. Conduction of heat through substances result of exchange of energy of molecules by direct interaction. This phenomena is greatly influenced by the flow of free electrons. The conduction occurs in solid, liquid, and gases. In solid, the high binding force do not allows any appreciable change in position of molecules, thus leading to poor conduction in liquids and gases. The conduction process is always associated with the convection. The radiation, the standing in the sunlight, one can feel the sun warm in spite of million miles of distance between earth and sun. Although there is no medium in the space to carry the heat to the earth, the sun thermal radiation reaches us within short period of time. This is the example of radioactive heat transfer. The radiation is the transfer of thermal energy in the form of electromagnetic waves. The radiations are emitted by every real surfaces due to atomic or subatomic non-stability. The sun also receives the energy from the earth continuously, as no one stops the earth from emitting the radiations. All electromagnetic waves travel at the speed of light and can pass most easily through the vacuum. Convection. When the wind is blowing, the flowing air carries heat away from our skin and we will feel cool. This is the example of convective heat transfer. At a microscopic level of studies, the convection may be designed at conduction through the film of fluid associated with the transfer of energy due to the mixing of fluid particles. Thus, the convection is not an independent mode, but it is so commonly occur process in a heat transfer, sometimes given a status of independent mode. The convection heat transfer is strongly influenced by geometry of surface, the level of turbulence in the fluid and various fluid particles. Hence, from the analysis point of view, it is very complicated process. The prime objectives of heat transfers are First one is quantifies the rate at which the system gains or loses the heat energy. The second one that identifies the mode by which the energy is transported. Third one is predict the temperature difference or temperature distribution throughout a body. Next important objective is develops a method to accelerate or retard the rate of heat flow as per the requirement. And last one is provide the analysis of various heat transfer equipment such as heat exchangers, evaporators and condenser etc. Next one is applications of heat transfer. The heat transfer phenomena plays the important role in many industrial and household applications. Some of the important applications involving the major consideration of heat transfer are considered for this presentation. First one is the sciences like metabolism, human comfort is the primary deals with the heat transfer. Second, the cooling of sensitive electronic components in computers, the rocket used for the launching the satellites, HVAC systems, microwaves, underground water pipes, etc. are the several areas of heat transfer must be considered. Third, the houses and building using the air conditioning system, the heating and chilling chambers required food processing units. Next application of heat transfer is the processes like evaporation, distillation and crystallization. Next one, the cylinder of IC engine must be cooled from proper functioning. This cooling process demands high rate of heat rejection from the components such as cooling jacket, radiator, on the hot exhaust manifold and pipes. Same is demand from the cooling arrangement around the brake rotors. Next important application is melting of metals and plastic for the molding processes. And next one is the equipment those generate the steam just like boiler and the devices which utilize the steam to perform the work just like turbines use almost all theories related with the heat transfer. The next important point is conduction. The conduction is the important mode of heat transfer. The conduction is a mode of heat transfer in which the flow of energy through the substance takes place without any appreciable movement of any individual molecules. The conduction takes place because of two modes of mechanism. First one is lattice vibration and second one is flow of free electrons. The lattice vibration and flow of free electrons as shown in this figure. The lattice vibration, the molecule of every substance continuously vibrate in the random orientation about same mean position. These vibrations are known as lattice vibration. While vibrating, the neighboring molecules collide with each other. At the time of physical contact, the exchange of energy takes place among them. This process occurs repeatedly and the results in the flow of energy through the substance. The rate of heat flow due to the lattice vibration depends upon the number of collisions taking place per unit time. The next important point it is related with the flow of free electrons, means it is related with the conductors. The vacant electrons in the outermost orbit of an atom get excited to availability of energy. They overcome the binding force and become free to move anywhere within the boundaries of the substance. These electrons are known as free electrons. While the moving from one location to another, these electrons carry certain amount of energy along with them. Thus, they contribute the conduction. The conduction process occurs in all the phases of substance, just like solid, liquid and gases. But pure conduction is found only in solids. In liquid and gases, the conduction is always associated with the convection. Hence, we are going to focus our studies mainly to the conduction through the solids only. Applications of conduction. There are lots of applications of conduction. I have shortlisted some important applications of conduction. First one is it is related with the boilers. The in boilers, the heat flow from the flue gases to the water takes place across the tubes by conduction. In cooling of IC engines, the heat flow from the combustion gases to the atmospheric air and the cooling the water takes place across the cylinder walls by conduction. When the steam flows through the pipelines, then the energy losses from the steam to the atmosphere air across the pipe wall by conduction. The flow of energy from the cold chamber into the liquid refrigerant flowing through the evaporator tubes takes place by conduction. And last one is the heat loss from the furnace to the atmosphere air across the insulated furnace wall takes place by means of conduction phenomena. Radiation. The every surface continuously emits the energy in all possible directions. This way of flow of energy in the form of electromagnetic emissions is known as radiation. The physical occurrence of this mode is not yet completely known. Still, the explanation and analysis of this phenomena produced by the following two theories. First one is wave theory or classical theory, and second one is quantum theory or Planck's theory. In first part, we will study the wave theory or classical theory. As per this figure, which shows the spectrum of electromagnetic waves. According to wave theory or classical theory, the electromagnetic emission propagate in the form of waves, depending upon the range of wavelength. The emissions are known as specific name as shown in the spectrum band. The wave is nothing but the propagation of disturbance created in the medium. In order to explain the flow of energy through the space, this theory assumes that the universe is filled with hypothetical medium is known as ether. Ever through the waves are emitted by surface with the different wavelengths, all these waves travel with the same speed as that, just like speed of light. The waves in the range of wavelength zero point 0.1 to 100 mu meter are emitted as the result of surface temperature and are significant in the heat transfer process. These are known as thermal radiation. The next important theory of radiation is quantum theory or Planck's theory. This theory is developed by Max Planck. It is stated that the emissions are in the forms of series of particles is known as quanta or photons. Hence, the radiations are also termed as photon gas flow. Each quanta possesses certain amount of energy which is proportional to the frequency of emission. The energy content per quanta is given by the energy content by each quanta is equals to Planck's constant into frequency of emissions, where Planck's constant is taken as 6.6261 into 10 raised to minus 34 joule second. The quanta along with the energy can move through the space with the same speed as the speed of light. On striking some other surface, the energy proposed by quanta get released, giving the flow of energy. Because of radiation theories, the Earth receives considerable amount of energy from Sun in spite of long distance between them. The rate of electromagnetic emission depends upon two parameters. First one is nature of surface and second one is its absolute temperature. The rate of emission is absolutely independent of surrounding conditions. The next important point it is related with the characteristics of the radiation. The first characteristic is all the objects at all temperature emit radiation. Second one, the distinction between one form of radiation from another lies only in its frequency and wavelength, which is related by, means the speed of light is equals to wavelength into frequency. The third important characteristic is a body at higher temperature emits more radiation of higher frequency. Higher the frequency, more is the amount of energy. Hence, the body at higher temperature emit radiation at a greater rate than the body at lower temperature. It is the most important characteristics. Next one, the conduction is a mode of heat transfer through a substance. Hence, we can say that the medium is essential for the conduction. For the radiation, the medium is not required for the flow of energy. It is also observed that in the space the rate of radiation increases. Next one is, in conduction the heat flow takes place from higher temperature to the lower temperature, while in radiation the heat flow continuously takes place in both the direction. A body radiating heat simultaneously receives the heat from other bodies as incident radiation. The net flow of heat is due to the difference between the energy emitted and energy received. Hence, when the energy emitted body is equal to energy received by it, then the net heat transfer by radiation becomes zero. But even then, the flow of energy is continuous. Next mode of heat transfer is conduction mode of heat transfer primarily depends upon the temperature gradient, means delta T upon dx, while the convection mode of heat transfer primarily depend upon the temperature difference. Thus, both these modes are dependent on the actual temperature of bodies. Means the radiation mode of heat exchange get enhanced if the temperature of both of involved surfaces get elevated by the same temperature. The example of this point is the radiation heat exchange between two surfaces at temperature 1000 degrees Celsius and 500 degrees Celsius is much more than the heat transfer between the two surfaces at 500 degrees Celsius and 0 degrees Celsius. Next important characteristics of radiation is, in the conduction mode, the intermediate temperature within the systems are decided by the surface temperature and the thermal conductivity of metal. However, the radiation mode, the medium does not get affected. The next point is convection. The process of heat transfer between the surface and surrounding fluid is known as convection. In this process, the flow of energy is primarily due to the movement of fluid molecules. When the fluid flows over the surface, a thin film is formed over the surfaces. The fluid molecules in the film flow in different layers parallel to the surface. The layer of fluid in the contact with the surface remains stationary. The velocity of other layers increases with their distance from the surface and finally becomes the same as the pre-stream velocity. This region above the surface is known as film region. The flow of fluid within the film region is laminar. Thus, no mixing of fluid molecules amongst the layers takes place. During the random vibration of particles, the particles in the adjacent layers collide with each other. At the time of collision, the exchange of energy takes place. Thus, we can say the flow of energy across the film region occurs due to the physical interaction amongst the particles, that is, by conduction mode heat transfer. Beyond the film region, the fluid molecules are free to move anywhere in random direction and they can carry energy along with them. Thus, the heat transferred beyond the film region takes place by mixing of molecules. Please note that the convection is a combination of conduction and mixing of molecules. Hence, it is not separate mode of heat transfer. As per this figure, the convection are mainly classified into two types. First one is single phase system. and second one is two-phase system. The single-phase system is further classified into two types. First one is forced convection and second one is natural convection. As per the two-phase system is divided into two categories. First one is condensation and second one is boiling. First point, it is related with the forced convection. It is a part of single phase system. In this type, the molecules of fluid are forced to move over the surface with help of some external force. In this type, we can get higher rate of heat transfer. In natural convection, the motion of fluid molecule takes place not because of any external force, but due to the inherent force such as gravitational force and buoyancy force. Condensation. When the phase change from vapor to liquid occurs by giving out the latent heat to the surface, which is at the temperature lower than the saturation temperature of vapor, this process is called as condensation. Boiling. When the substance undergoes a phase change from liquid to vapor while extracting the heat from the surface, which is at the temperature higher than saturation temperature of liquid, this process is known as boiling. Newton's law of cooling. The rate of heat flow in a convection process can be estimated using Newton's law of cooling. As per this equation, Q is equals to H into A into bracket T minus TF, where H average heat transfer coefficient in watt per meter square Kelvin, A surface area in meter square, T average temperature of surface, and TF average temperature of surrounding fluid in degrees Celsius. The formula given by the Newton's law of cooling is very simple, but the prediction of heat transfer coefficient H for the system is very difficult. In this session, we have studied the fundamental parts related with the heat transfer, objectives of heat transfer, applications of heat transfer, basic points related with the conduction, basic theories of radiation, characteristics of radiation, the important terms related with the convection, and Newton's law of cooling. This video is specially prepared for the understanding of basic concepts of heat transfer for the UG student. For more details, you can refer Heat Transfer book by Professor D.S. Pavaskar and Professor S.H. Chaudhary of Nishant Prakashan. Thank you very much.